What's new in Octave? Hi everyone, Thibaut here. This is your monthly rendezvous with Octave, the IoT edge-to-cloud data orchestration platform by Sierra Wireless. And today we have an exciting new Octave feature for you, Azure Device Twin connectors in Octave. But first, if you are not familiar with Octave yet, I recommend you to check out Octave tutorial videos first. You'll find them on Sierra Wireless YouTube channel. Okay, as usual, this live developer session is as well for you the opportunity to get your questions on Octave answered live, either during the session itself, if your questions are related to the topic of the day, or during the Q&A part at the end, otherwise. So please use the question box at any time for your questions. As you know, all Octave developer sessions are co-animated by members of Octave development team, and this one is no exception. So to take up this challenge today, it's a real pleasure to welcome with me today for the second time, Augustin Mont-Saint-Jean. Hi, Augustin.
Hello, everyone. Can you hear me well?
Augustin is Senior Manager and Octave Solution Architect at Sierra Wireless, and I'm sure you'll have a ton of questions for Augustin today. One more thing before we start. The session is recorded as usual and will be added to our YouTube channel in the coming hours. If you are watching this session on YouTube, check in the description below for the link to register to the live session so that you can interact with the presenters next time. It's free. All right, and without further ado, Augustin, the mic is yours.
Thank you very much, Thibaut, and hello, everyone. I'm really glad to be presenting you this developer session with, as Thibaut said, really exciting new feature in Octave, which is Azure Device Twin Connector for Octave. And so what we'll be reviewing today is 4 main areas before going to Q&A. First of all, the Device Twin Connector, why it really makes a difference overall and how it is a new step in the kind of connectors we have on board with Octave. Then I'll spend time to show you how to use the Device Twin Connector, its principles and how to best use it. And then we'll go through a live demo. And so I'll show you the tips and tricks to be using the Device Twin Connector, and also give you a view on the next steps with regards to connector on Octave. And you'll see that, yeah, we have new things coming in the very near future in terms of connectors on Octave. And then after that, we'll have the floor open for Q&A that you can start adding your question anytime in the chat window. So let's start with the Azure Device Twin Connector. So Azure Device Twin Connector has been available in Octave for a bit more than a month now as a preview. So it's fully available. Every one of you can use it, and it's I would say it's production grade. But we'll still have collecting feedback from early adopters, making a few improvements, mainly in terms of UX. But it's fully functional, and you can start using it today if you haven't even started doing so. So why does it make a difference? Here's a quick recap of the connectors we already have in Octave since more than a year now, which are generic connectors we have in Octave, whether it's HTTP connector or an existing IoT Hub connector. The way these connector works is they're really convenient features to take up any data that is reported by your Octave devices. So from assets to the cloud, to the Octave cloud, through the orchestration tools that you know with Octave. And then connectors make it really easy to push data to your own cloud in terms of telemetry. So data reported and streamed from devices. Why connectors makes that really easy is that they're built to push data from the Octave edge to the streams and to your own cloud as telemetry. These connectors handle the easily configuring the endpoint. It also easily handles any retries. So if your cloud is down or rejects when it's just pushed, the connector will hold the data for a little while and retry to push it again. So it handles those mechanisms automatically, so nothing you need to implement to have that done. So that's really convenient. And it also handles either easy configuration or automatic computation of the required authentication headers to push the data to the third-party cloud you are targeting. So that's what we introduced more than a year ago, and many customers and developers are using it. They're really convenient. Now, there are some things that remain to be done when using those connectors, are handling the, I would say, the control of the device from the cloud. So either configuring a device or sending commands to a device. So this is really easy to do with Octave, but in the case you're using this, I would say, connectors we had until now, you needed to use Octave API calls to change device configuration or to send commands to the devices. So it's really easy to do, but whenever you have a legacy cloud, which is already built to do two-way control of devices, so collecting telemetry, getting reports on the device status, but also being able to send commands or to update any device in the field based on an existing twin within the cloud. You can do so with the current connectors, but you need to go through the Octave API. So why does the Azure Device Twin Connector make a lot of difference here? The main difference, as you will see in this diagram, is that this Device Twin Connector not only handles the telemetry, even with some improvements on top of what we already have, but handles telemetry. So any data collected from devices is sent to the third-party cloud in Azure IoT Hub. But there are two main functional blocks that are added in the connector and which make it a two-way connector. And this is where the main difference comes from. So it's with the Device Twin, Azure Device Twin Connector, it's really easy to send commands to an Octave device directly from IoT Hub. So any tools used to handle IoT Hub, so either development tools or the IoT Hub API on a production system. So commands through direct methods, and also a two-way, we call it two-way mirroring of the Octave device configuration with its device twin image in the IoT Hub, meaning any change made on the device twin, so the device configuration through any tool, through API calls to IoT Hub, is automatically sent and reflected in the Octave object model in the Octave cloud, and then which handles the mirroring with the actual device in the field. And any updates on the device status that gets to be known by the Octave backend is immediately reflected in the device twin so-called reported properties. So this is really convenient if you have a legacy system or building a new system where you have you want to have a really streamlined implementation. You just use this two-way connector and control everything from your platform, your own cloud, more at the application and end user level of your cloud application. So there's no need, in short, there's no need to make extra Octave API calls to send a command to a device or to update device resource configurations. So how to use the device twin connector? You will see it's a few simple steps, which are pretty much the same as what you already know with Octave Cloud Actions or Octave connectors. So to configure the connector, the way to associate devices to an Azure Device Twin connector is based on tags, so which is the generic way in Octave to associate given set of devices to an orchestration tool in the Octave backend. So whether it's a cloud action, a connector, or specifically this Azure Device Twin connector. Then obviously, as we are interfacing Octave with a dedicated component in Azure, Azure IoT Hub, you need to provide the Azure IoT Hub credentials in your connector configuration. And there's a really simple way to do so. It's just copy the connection string from the Azure portal, copy that in the connector configuration tool, and everything will be automatically populated, and your connector will be ready to use. Now, focusing more on the connector features and functions, what you will need to configure is which telemetry you want to collect from devices and send to your own, to the IoT Hub, your own cloud IoT Hub. So telemetry coming from the devices. And this is where you have a simple drop-down list to select any streams. So it can be one streams or as many streams as you like coming from your devices, and tell the connector to collect anything coming in those streams and to push it to the IoT Hub as telemetry. And optionally, as we always provide the capability to do customization, either in the event formatting or changing the headers, that is sometimes needed, we provide an option to add your own custom JavaScript event processing and event formatting so that you can easily adapt any event structure on the fly within the connector before it's sent to the IoT Hub. So you just need to configure that part of the telemetry, what you want to report, and then all the features which are the totally new feature, which are the device twin mapping and the ability to send commands. These features don't require any specific settings. So as long as you enable the device twin connector, those features become immediately available for any device which is tied to that connector through the tag-based mapping. One key thing, the second key step, it's just the initial provisioning on the device side. Devices need to be explicitly declared in the IoT Hub. So you would typically create your provisional list of devices in the IoT Hub and get names or IDs for those devices. And in the same way, once this is done, when you provision your Octave device, so claim them on board the platform, so just typically import a file with a list of your devices. You'll also be able to indicate which IoT Hub device ID is associated to each of these, and based on that, the connector will automatically map the proper device to the proper device twin in the Azure IoT Hub. And one key part, if you want to start using this connector right away after this presentation, everything is fully documented at the same usual place in the Octave docs, and you have the link indicated here. Just search for device twin and you'll find it directly. So in short, what does the UI look like for configuring the device twin connector? So coming back on what I just said, you have some properties which are the credentials of your IoT Hub. So you set it up in Azure, and you give it a name, you enable some accesses to it, so a shared access key, and by just copying the string or manually setting the device name, the IoT Hub name, the shared access policy, and the shared access key, you just configure this, and from there you will have enabled the connector. And the first thing that I indicated is that to map devices to a connector, you'll just have to indicate which source tag you want to use. So you just have to set one and only one tag for a given connector to tell that connector which devices it should handle in terms of device mirroring. And you'll see in the live demo there's a nice tip and trick to figure out and to check which devices are handled by the connector. Then second, as I explained, the key part is to select which streams, and this is something which is new actually in terms of connectors. The previous connectors, the other connectors that we have only collect data from one given stream for many devices, but one given stream. Here you can simply pick up as many streams from devices that you like. So this is really gaining one step in the configuration. If you want to aggregate multiple streams, you can easily do so without the device twin connector with an intermediate cloud action to aggregate streams, but it's one step that you need to code. It's just a few lines, but you need to set that up with the legacy connectors we had before, and now it's all straightforward to do all at once. So you define which streams you want to pick up to collect data. And then if ever you want to process, you're just filtering out one key out of the reported events, but you can have more complex code here to pick up anything in the data points and format it as you want before it's pushed to the IoT Hub as telemetry. And in terms of configuration, that is basically it. So just to summarize what I just said here in a given picture, assume you have a set of devices on your platform, and some of them have a given tag. An extra device does not have that specific tag. Then when you just configure your Azure IoT Hub device twin connector with that specific tag, your connector will handle all those devices with that specific tag and not any extra device which doesn't have that tag. And then assume your devices all report multiple streams, 3, 4, 5, how many as you want. If you just want to collect data from 2 of these specific streams and report it as telemetry, you just have to list them in the connector configuration, and any data reported in those 2 streams for all the devices with that tag will automatically be pushed as telemetry in the IoT Hub. And once again, as soon as devices are mapped in terms of tags and they're provisioned both with an ID in the IoT Hub and I'll show that to you in the UI, that the devices are provisioned with the same ID in the Octave platform, then you're immediately available to target devices through direct methods, and you automatically enable the device twin mirroring. So just before we go to the demo, just to give you to show you which tools I'll be using to do the demo, so that it's things are explicit. So obviously, when you set up a device twin connector, your whole fleet, you have defined your desired blueprint, your orchestration models, your streams. You have set up your connector, the way that things will work in production. Will go to the other layer of the customer cloud, so the actual application, data storage, BI, visualization tools, control tools that come behind this. But everything at the end will be controlled through the IoT Hub API, which will collect and control data from the IoT Hub. Today, I won't be using the IoT Hub API, which is not it's a good tool for production, but not really explicit in terms of demo. So I'll be using some tools with an actual UI and display, and you can easily use those tools as well when you want to try this connector. So there's one tool called Azure IoT Explorer, which is a desktop tool. So you just launch it and provide your IoT Hub credentials, and you can visualize and control your devices from there. And you can also control your devices through the Azure web portal. And I'll actually be using both. So when I will be showing telemetry in the demo in a few minutes, for that, the screen you'll see is the Azure IoT Hub, Azure IoT Explorer tool. And for controlling the device twin and sending commands, just to have 2 windows, I'll be using the Azure web portal to do so. So now let's switch to the demo. So. Okay. So the environment I'll be showing you here in terms of demo, I'll have, the Octave user interface. So I'll have one tab with the device, one tab I'll switch to show you the connector configuration. Have one screen with my device twin, which shows up. So this window here is the Azure IoT Hub web portal. And so here I'm monitoring the device twin of the device that I'll be using for the demo. Another tool for sending direct methods, and provide, if we have time or if you have any specific questions, I'll be able to share and show you how to configure and collect the configuration strings that you need to use to set up the device twin connector. So what is the actual use case I'll be demoing here? So here I have a demo device, so fully live and connected, and it's running an actual use case. So what it's doing is reading data from several Modbus sensors and running some logic to compare the values to thresholds that we can control from the cloud, and I'll show you how to do that from IoT Hub. So it's running a given logic and collecting data from Modbus and sending some constructed JSON objects in one given stream, which is the device default stream. And besides this, I'm just reporting analog data. So I have one GPIO from that device, which is enabled and reporting analog data. And so the way these data are reported are that I have this ADC0 stream where the analog data is reported. I have this default stream here where all the payloads computing by an edge action, collecting data from Modbus are reported. This is actually the same setup that you saw last month in the Octave Modbus demo use case that was done by Cédric Poirier. So same use case, I just added this collection of analog data to show you how we control that. And on top of that, I'm reporting some signal data every hour. And this one is just for internal logic within Octave. So we don't want to report that one to IoT Hub. And so you'll see how it's easy to define that I want to report data coming from the default stream from this analog digital converter stream, but not from the signal stream. And then in terms, just to show you in terms of resources when we'll be using commands, I do have two virtual resources which serve as thresholds. Once again, some use case that was demoed in the previous session. So I have two thresholds that can be controlled from the cloud. So last month we showed how to control it from IoT Central. So here you'll see that these thresholds, I can easily control them by sending direct methods from the IoT Hub user interface. So with that set up on the device side, let's just look at the connector configuration. So sorry, I omitted to show you. So this device has a specific tag, so just called the twin tag is true actually. So this is the tag that I'm going to use to associate that given device to the connector. So this is the dtween true tag that is here. And now to make sure that my device is properly reported in Azure IoT Hub, I have gave it a name which is the same as the name or the ID under which it has been declared in IoT Hub. So this is the name that my device will have in the IoT Hub, and there's a flag which is automatically enabled by default when you create it, and here it just tells the system that I actually want my device here to be mirrored in IoT Hub. So one convenient trick when you have this tag here, what the team has added, is a nice shortcut with whenever you have that connector icon, you just click on it and it directly sends you to the connector which is handling that given device. So it's a really convenient shortcut when you're looking at a given device. You know, it has a tag, it's handled by this little icon telling you there's a connector mapped to that device. It's easy to have a shortcut and just go to the connector which is handling that device. So in the connector, you easily configure just the name of your IoT Hub and the generic access key that provides control of the IoT Hub. So it lets the connector retrieve the security keys and make sure they're always up to date in Octave to send updates or to interface the device with IoT Hub. Now, in terms of coming back to our use case, as I said, we have three streams reported by this device. So the default stream, the ADC0 stream, and the signal stream. Here, I just want to report two of these. So I just selected the proper streams in the drop-down list, and this is how my connector is just reporting these two streams and not any other data coming from the device. And as I don't want to push all the metadata coming from the devices. I just want to send the payload, which in Octave is the event.lms key. So I just tell the system push the elms part of the payload to IoT Hub. So one extra information that might be really useful, and we have our large customer using this already, is the dynamic headers. So once you push data to IoT Hub as telemetry, here it's a simple use case, but you might have a lot of data coming and being reported from your devices to IoT Hub, and depending on the nature of the data, so which stream it's coming from, which device, or which data point it is, at the other end, the IoT Hub telemetry might route that data to different pipes, which might be live streaming of data, which can be some hot storage or cold storage. So here for that, you can use headers. And here it's a simple case where I tell the system to dynamically look at which path data is coming from. And if it's coming from the ADC0, so the analog digital converter data, I just return that the route it should take after it reached the IoT Hub, it should go through the hot data stream, and any other data, so typically here things coming from the default stream, will be tagged to a route, which is the cold data stream, and you will see immediately in the Azure IoT Explorer that this is what we get on the other side. So here I'm switching in the Azure IoT Hub. We're looking at the telemetry, which is reported by our device. So you can see it's being updated in real time. And if you look at what is coming, we mostly have some data coming from the analog digital converter, since it has a higher period than the Modbus data, and it's tagged as belonging to the hot data stream. And here we just had a data point pushed on the default stream, so that Modbus data, so all the raw data that has been pushed, and you can see that it has been tagged to the cold data stream. And so this is a live view of things going through the connector, exactly related to how we have configured it. So collecting data from two streams and dynamically computing which route we want that data to go through once it reaches the IoT Hub. So this is still, as you can see, really convenient and flexible and powerful, still in the way of how to report data properly and push data properly from Octave to IoT Hub. Now let's look at how we can actually control the Octave device from IoT Hub. So here what we will do, we have this analog digital converter, which is running, which means that, as you may know, in the Octave world, it means that there is a resource called ADC, and which is enabled, enable flag is set to true, and it has a given period. Now, if I want to change that in the Octave world when you're developing, you can easily do that from the UI when you develop. But when you actually want to change that in production, either with former connectors, you would make API calls to Octave to change these configured values. Now, what you can easily do from IoT Hub directly through this two-way mapping of the connector, you can. So here, let me just show you the framework. I'm just in IoT Hub. Sorry, I went one step further than I wanted to. So here I'm just in my IoT Hub looking for the list of devices and picking up my device called FX30 Augustin. And I want to use and control the device twin directly from here. So you can see that there are desired properties. So these are the properties that you actually want. You're in the cloud, but these are the properties you actually want the actual device to operate with. So what you can do, you can change any value. So let's see here. I will reduce the periodicity, the period on this ADC. So to 2 seconds, it means it's going to read the ADC data faster. So I just save this here. So it's changed the device model in IoT Hub. And when you see, if you go back to the Octave device, you just saw it was spinning a bit here. So it's 532. So just right now we had a configuration start. So it meaning the Octave platform received the change, sent it to the device, and the device reported that it got the new value. And as you can see now, the analog digital converter data is being read at a much faster rate. I have much more analog digital data points in between the Modbus readings. And if I just want to shut down this ADC readings directly from IoT Hub, I just set that value to false. When I do so, if you see here, the device little box here is spinning, meaning the device is being updated based on the change I just did directly from the Azure Device Twin object. It received a new configuration, completed that, and what you see, well, it's not necessarily easy to see, but ADC data is not flowing anymore, and it will just have some data reported based on the slower reporting rate coming from the Modbus data. So that's for device configuration that you can change, meaning in Octave, when you change a resource configuration, it means it's changed its default value. You change it, and if you restart the device, it will tell the device to in any case, start and use that value. In Octave, if you just want to change the value of a given resource for a given period of time, but if ever the device restarts, or you want to restart it to start with default values, it will not keep memory of that data if you sent a command. So the way to send a command is to use direct methods. So what I'm going to show you is how to do that. Typically, the way I'll use command here is to change the threshold. So here I have some Modbus sensor readings, so with dew point, humidity, temperature readings that are done, and the edge action is comparing those values to a threshold. And if the values are below the threshold, then the alert state is 0 and data is reported at a slow rate. So what I will do, I'll just reduce one of the thresholds, and you will see that the edge action behavior will change based on that. So let me just, sorry, this is not where I wanted to go. So to do that, we're going to send data, send a command to a device. So you see, I did some changes an hour ago. So now what we want to send, the current value is 90, so 90%, so pretty high. What I want to take back is the former value, so a low threshold value, so that the actual sensor reading will be above that threshold. And I directly want to send that from IoT Hub. You could easily doing for development purposes, do it from the Octave UI or do it from an API call, but here I'm going to show you how to do it from IoT Hub directly. So to send a command to the device, it's pretty simple. You just need to use a method named command and send whatever structure. So here I'm targeting only one resource, but you can target as many resources as you wish directly. And so you just construct that command here in this tool or through the IoT Hub API and invoke that method. And once you do that, you can just see less than a second after, I had this specific command. So going through this direct method, through the device twin connector, two-way. So here I'm handling direct method and sent to the device. And so if I go here, I can see that there's a command which has been sent to the device a few seconds ago. The command has been completed, meaning the device has received it. And now, if you look at the stream here, you can see the actual command sent to the device. And you can see that now the device is reporting alert state being 1, meaning one of the values, which is the humidity. Actually, it's reading 46 and the threshold is 10. So it's in an alert state. And so we did all of this here directly from Azure. So as a recap on this, the key point is really that with when you're operating a device, so you develop your use case, you come up with your blueprint, which means your device has its edge actions, it has its streams, which are used to report its data. It has some resources or virtual resource that are used to control the actual use case that you want to implement. So all the development that you want to do around your use case, you will do it in the exact same way as you've done until now. Now, in terms of end-to-end integration, if you want to so directly tie your Octave device to the IoT Hub device twin. You just need to set the proper tags and associated device ID to your devices and enable them through this device twin connector, just picking up the streams you want to report, optionally how you want the headers to be handled, and everything related to the device twin and commands is done automatically. You can immediately control your devices from the device twin and from direct methods. Maybe one last thing in the demo before I come back to the next steps, evolutions on Octave. One thing I did not show is that here I showed full control of changing the desired properties of the device twin model and having them propagated down to the Octave device. Things work also in the reverse way, meaning anytime you make a change, so if I change something here, it will be propagated down to the Octave device, and as soon as the device has acknowledged that the state has been changed on the device, it will report its own property, and actually it reports all of its properties. So in the Azure device twin object, you will see all the current status of your Octave device being reported. So full status, and whenever you make a change, by the time that the change has reached the device and been acknowledged, you will see that the reported property will match any property that you just have configured. One other key thing to consider is some of the key benefits from Octave as an all-in-one platform, even with adding this Azure Device Twin connector, is that the flexibility that the Octave platform brings, meaning taking an example where you would change a property here in your device twin model, it will be sent to the Octave backend. If ever at that specific time the device is not online because its use case makes it not to be online, or if it's moving and out of coverage at that specific time, or cell tower is down at the time you make the change, any change that it propagated from device twin through to Octave backend through the connector, Octave will do its usual job, which is to hold that data, that command or configuration change for the required time, and then push it to the device when it comes back online. And when it comes back online, it will report that it got the change, and you'll see things reported in Azure IoT Hub. So this is really where Octave makes a difference. If you just implement things directly from a cloud platform through whatever wide area network, direct cloud platform to your asset, if ever you make a change and the device is not there to get that change, then that changes a lot. So you must have to push changes again. Octave is doing that for you in a fully transparent manner.
And Augustin, today we are focusing on Microsoft's Azure IoT Hub platform, but I guess that if you use any other web platform like AWS or any other one, you'll have the same features coming from Octave, right?
So what is that's a really important point. Actually, so here we started with this Azure Device Twin connector. And as you see, what it brings is not, so it's based and related to this device twin connector, but what it means in terms of the Octave product is, what is new there is really this capability to have two-way mapping. And yeah, if you need to remember one thing that from this presentation is that what is brought here is Octave now has the ability to do a really powerful and simple two-way mapping of your asset to your own cloud. So here we've enabled it on the IoT Hub device twin, but now we have this logic in place. It's easy to apply it to other clouds, and so we do have a lot of other connectors in our roadmap.
Great, thanks.
And just as a next step, which will be 3 minutes, I think not more. And on top of what we just discussed, so this new type of connector being really a new way of enabling edge to cloud interface and device orchestration and interfaces. What we'll soon be bringing, so on top of this connector, which is, as you understood, available in preview, fully documented, so you can start using it now. What is coming really soon in early July is an extra, but really one big step again on top of what I just showed you is this Azure Device Twin Connector plus what is called, or what we call, the device provisioning service. The device provisioning service is really one stage, and I guess we'll have a dedicated session once this is out, that even makes this more powerful and easier to operate. What this will bring is simpler provisioning. So rather than having to provision devices in Octave with a given ID and the same ID as you have provisioned in IoT Hub, you will actually do everything in the device provisioning service, which is a kind of a bootstrapping server. And when devices report through Octave, they will get their own name, provided that the hardware is registered. They will get their name, they will get their security keys, and do that automatically. So the provisioning will be much simpler. And what is also really fundamental for large fleets, so the steps we're making here is really making Octave and bringing Octave multiple steps further in terms of how you'll be able to scale with Octave, deploy a much larger fleets, handle redundancy and fallbacks, is the ability to have, so here IoT Hub, but multi-clouds. It's the ability for devices to show up, to go to Bootstrap server, and that server will tell the device, so through the Octave connector, you need to connect through this endpoint. So in this case, this IoT Hub, and if there needs to be load balancing or direct devices to a new endpoint because one is down in one given region, this will be handled automatically. So multiple endpoint support with load balancing will be supported once we have this feature out, and a few other, I would say, nice features to make the device configuration even easier, where the device twins can be provisioned with default configurations, so that any device, depending on which platform they end up being routed to, might have a default configuration which are automatically provisioned up front.
Augustin, I have a question for you.
Yeah, and that's perfect.
Provisioning service available for Octave deployments using Azure? Is it only available for Octave deployments using Azure?
So the device provisioning service?
Yeah.
Yes. So yes. So what we'll be releasing in July is really strongly tied. So it's an Azure provisioning service. So that really comes on top of IoT Hub. So it's strongly tied to it. So we're really pushing the full story to the maximum extent here. So with the DPS, we'll have I would say the full story implemented on the Azure IoT Hub connector. And once again, it's really bringing the capability to have these automatic provisioning, bootstrapping server, load balancing, but now we have the framework in place and even developed and released on the IoT Hub and DPS. We'll then be able to expand that to other platforms which have similar mechanisms.
Thanks. Any other question for Augustin? That's time now for, this is the question and answers part of the session. Some of you guys already asked me to contact you back after the session, so that no issue. If you want us to contact you back, we'll do that in private right after the session. So I've taken your contact already. Any question? Any more question for Augustin? No, it seems not. So Augustin went quite quickly through all different Octave concepts during this session. So and most of them were already covered by previous sessions, developer sessions. So if you feel that you need some explanation related to I don't know, resources, ejections, tags, whatever, go check out the previous sessions in our YouTube channel, and feel free to if there is anything, any suggestion for a topic you would like us to cover, feel free to suggest as well. One question is coming from Sudhir. Is there a way to tap into the data before it gets into Azure?
If I understand the question well, the answer is yes, meaning that you have data collected at the edge. So then you have the edge orchestration where you can fully control, filter, orchestrate, and even format how you report the data. It makes it to Octave streams. When you enable the connector, so you pick up the telemetry, the streams you want to pick up in terms of telemetry, but this is where you have custom JavaScript functions. So if you want to intercept, filter to, in some cases, not send data if it has given values or formatted in a given way, or add extra data, you can totally do so, both in the payload, but also in the headers and metadata. So fully possible to do so.
Yeah, and that's a great feature of Octave as well. Thanks. Any other question for Augustin? Yes, I see. Okay, another question. Is it possible to write an edge action, edge programs? So I guess it is edge actions in other programming languages than JavaScript.
No, for the time being, at least. No, the framework, the approach with Octave is to have this simple language, the same being used at the edge and with the cloud. So with the with the Octave framework, it's JavaScript only, both at the edge and in the cloud. Now, further down the road, I would say things might there might be some evolutions down the road with extra features, extra capabilities, but at least nothing for the immediate short term on these topics.
All right, and Ian saying that just to confirm, will at any point be partial BP option be available? So BP
yes,
partial. Okay.
I know the question. So that's on our plate. A lot of among the many improvements that we're looking at. So yeah, there are designs we're working out on, but yeah, when that would be released is not yet planned among the all the things we have, great things we have on our plate, and that we want to deliver.
So thanks, Jan. So we'll keep in touch with you on that one. All right. Is there anything else for Augustin? Oh, yeah, I see. All right, you're welcome. So okay, so thank you guys. So for any more questions, you can reach out to us on Octave forum. Both Augustin and the whole team at Octave are on the forum. You can reach out to us there. You have the URL here on this slide. And I think, so Augustin, if we can go to the next slide, I think we can wrap up this session for today. Next time, it will be July 8th. So in 1 month, same time. With someone else. maybe Augustin, you'll be giving your chair to someone else in the team. So as I said, if you want to register for the next live session, because I know that a lot of you guys are watching this session after the live on YouTube, just go to the description and you have the link to attend these live sessions, and you'll get the opportunity to answer to get your questions answered live. You can contact me if you guys like to present a use case or anything of interest you are doing with Octave. That's part of what we are offering you as well. So feel free to contact us. You can follow us on Twitter, Sierra Developer, and of course, subscribe to our Sierra Wireless YouTube channel if it's not already the case. All right. Thank you, Augustin. Thank you, everyone.
Thank you, Thibaut. Thanks, everyone.
And see you next time, July 8th. Bye-bye.
Goodbye.